class one. Yesterday, day before yesterday. Yesterday, you called your class. Okay. So I guess there is no students. So that's quite provision, whatever we have done in the last two classes. In the very first class, we had a discussion about the computers, what the computer is all about. The main component of the computer, what a computer will understand, all these things is what we discussed in the very first statement, right? Computer can understand only machine level language. And if we are writing code on medical language, if we directly give it as a computer, it cannot understand. Correct? So we have to make use of one software. Which is that software? It is compiler. So compiler is one software which we convert this compiler language code into machine language code. This is what I have discussed. Apart from this, there are few more things. Yeah. There are getting experiencing. So we have discussed about these things, and yesterday's class, our discussion was all about it was all about the different programming languages that we have to picture. Not many, just few the few important languages is what we discussed. So you understand how the transition happened. The demand change. When demand changed, many different new programming languages were invented that made the evolution of code. Okay, so this is what we have discussed till now. What are we going to discuss in today's class? Maybe a very important topic is what we will have a discussion about. What is that? Yesterday I just gave a question. What was the question? Let's say you have an 8 GB RAM and 12 GB RAM. Out of these two, which one are you going to purchase? So many of you said that you want to go for 12 GB RAM. Why that? I did it again, not just now only I'm going to tell you. Please wait for some moment. But dear students, I hope you know who is Steve Jobs. You know who is Steve Jobs? Steve Jobs, what is Steve? Yes. Online students, have you heard of Steve Jobs? Online students, please respond. Have you heard of Steve Jobs? Yes. Okay. Nice. Who is learning? 6. Okay. Right. Okay. Maybe perhaps 6 also most of them will tell. What if you know the iPhones? iPhone. Everyone know iPhone? Yes. Yes, you are going to okay. You get this. So Steve Jobs once said, great Steve Jobs said one thing once. That is, if at all you want to learn anything or you want to be a good software engineer, you should understand the hardware that is present below them. Software is what you start writing the codes, you start designing things. But if you really want to be a good, very good software engineer, you should understand the hardware that is present below or that is present inside. Similarly, now that we have had a discussion, you understood that our discussion was completely about one hardware device, which was that microprocessor. Correct. Now it is time for us to understand a few more hardware devices. Because from next, it will be completely about the software, coding, everything. But from the basic, when you are starting understanding the hardware, from the basic is very, very important. Okay. Now, what is that we are going to discuss this? We are going to talk about the memory devices first. This is clear to everyone. So, what really the memory devices that we are going to speak about is what we are now going to talk about. You already know one of the memory devices right now, which is that the microprocessor. Maybe I am going to write a microprocessor, not this side, but again, that's it. Okay, but I will tell you. So I hope this much is clear. Yes. Yes, students. This is the microprocessor that I am having here for my system. Okay, so microprocessor I will represent it like this as E. Tell me what type of memory device it is? It is made up of. Yeah, exactly. Showing device. What is used for designing this hardware? I have told this.
Is how to keep it semiconductor.
Yes, it is a semiconductor device. Because in order to develop the hardwares, you need some device, right? I mean, you need some material. So it is what type of material? Using semiconductor type material, they have designed microprocessor. So microprocessor will be of semiconductor devices. And does not understand zeros and ones, all that you understood. Now comes another important part, which is the memory device. Tell me, if you don't are storing anything it can be. Maybe you take a photo, you click a photo will be there.
As I was speaking, as the great Steve Jobs once said, what did he say that? He said that it is always recommended to become a very good software engineer. You should know the basic things about the hardware that is present below that. So any software while you're designing, you make use of computer. Inside computer, the main functionality you have already understood, which is a semiconductor device, which happens to be the microprocessor. Now, let us try to understand another important device, another important hardware component, which is the memory device. Dear students, I hope you all have heard this. What is that? Any functionality or anything that you're storing will be stored somewhere. And where it will be stored, it will be always stored in one of the memory device, which we tell it as what? Which we tell it as? Maybe I'm going to represent it like this. Which is this memory device? This is the hard disk drive. Which is it? Hard disk drive. Agree, everyone? The storage. So anything that you have will be stored where? Will be stored in this hard disk. Now, let me tell you what type of memory device or what type of device this is, I will tell you. Definitely, this is not a semiconductor device. It is what? It is made up of magnetic technology device. Are you understanding? It is made up of magnetic technology device. That is semiconductor, right? It is made up of magnetic technology. Now, let me tell you a few things here. You have to understand. What is that is, whenever there is a semiconductor device, the semiconductor devices are very fast in execution. They're very, very fast in execution. But whatever these magnetic devices are there, they are very, very slow. They're very, very slow devices. Now, what is going to happen is processing and all will happen here. But whatever the data or anything that we have is stored here in the hard disk. Processor, how fast it is, if at all I tell some work to do, it will just do it in within fraction of seconds and it will give the output. Fraction of seconds. But this will slowly send the output. I mean, whatever the necessity is there, it will send that to there. You only think fast, slow. By the time it sends one thing, it will execute and it will give, it will be just keep on waiting. By the time again, one more thing will come slowly. It will give here, fast it will execute, it will give. Can you see that there is no compatibility here? Are you all understanding? So let me tell you one important thing to all of you, that is internally, these two devices will not be connected. Are you all getting it? Internally, these two devices will not be connected. That is why there is one more device, which is that device, if you ask me, which is RAM. Are you understanding? RAM. What RAM stands for? Very good. It is random access memory. Okay. Now, this device is what technology device? What do you think? Is it semiconductor device or is it magnetic device? Just a guess I am asking. You all can guess. I will give you a hint, okay? One hint I will give to everyone. I told you only told me when I asked you which RAM you will go, 12 GB RAM because it is faster, you told. So what can be RAM? Something that is faster. Which one is fast? Out of semiconductor device and magnetic device, which is faster? Semiconductor device. That's it. You all know it. So this is what? This is a semiconductor device. So this is also fast, very fast in execution. Now, dear students, internally, how the connection will be there is, you have heard about the connections. Here, it will not be wired connections. It will be connected through something called bus. You have learned this, right, in your academics. So they will have the connections with the bus. Again, ma'am, bus means the bus which we travel? No. Whatever the connection path is there, we call them as bus. And from this device to this device, again, it is connected with another bus. Now, important thing is there. You have to understand, all of you should understand. What is that is? Anything you write, okay, anything you write, it can understand only ones and zeros, all these things you know, the voltages. But dear students, you have to understand that, let's say you are working on a computer, one document you are preparing. Are you all getting it? One document you are preparing. While you are preparing the document, anything, if at all, is in the process, it is doing some process, which means it is active. If at all you are writing a document, Word document will be active. You'll open a computer. Now you want to write some document, one document you want to prepare. So you will go and click on Word document. When you tell that, it will open, right? Yes or no? Word document will open. On that, you will start typing. Whatever you want to type, you will type. Now, when you're doing that process, at that time, where that Word document will be present, it will not be present here. It will be present on the RAM. Are you understanding? Anything, if at all, has to work, it will be present where? It will be present on the RAM. If some process should happen, it will be present on the RAM. Now you're done with the work. Coding, everything is done. Now you want to permanently store it. Are you all getting my point? You will write one program. I will ask you to write one program, Java program. I will ask you to write. You will write. To write a program, you will open some notepad, Word, or any of that you have used. While you are doing that process, when the process is happening, that time it will be happening on the RAM. Please understand. Now I want to permanently store it. Now the important thing is going to come. What is that is? If at all you want to store anything permanently, you cannot store it on the RAM. Why, ma'am? Why? Because this RAM is there, right? The semiconductor devices are there, right? They are something called volatile in nature. What do you mean by this volatile? Volatile means it needs continuous power supply. Are you understanding? It needs continuous power supply. I will give you a small example. You will get the clarity. What is that is? If at all you have been to your labs, in your exams, you will have labs, right? In every semester. You have gone to computer lab. You will be writing one program. Your lecturer will be keep on telling in the lab, save your program, they will be telling. Why? If at all power goes, current is not there, power goes, the system will get off. Again, next time when you on it, if at all you have not saved it, the document is lost. Yes, you would have heard this, no? Yes or no? Why? Why? Because when you're typing, if at all you have not saved, where it is present? It is present on the RAM. RAM needs continuous power supply. If at all power goes, RAM is not active. There is no continuous power supply. So whatever is present on the RAM will just get erased. Are you understanding? Now, that is why you will do that saving process. Understood? So when you perform saving, what is going to happen is whatever is present on the RAM will shift to hard disk and it will be stored permanently. Are you understanding? So this process of storing the document or storing a file permanently on the hard disk, that process only we call it as saving process. All these days we were using save, save, save. What do you mean by save? If you want to keep something permanently, that is saving. But what is happening in that saving process is anything that is present on the RAM will be shifted, will be stored in the hard disk permanently. Ma'am, why hard disk only? Why hard disk only is because hard disk is a magnetic device and magnetic devices are non-volatile in nature. Are you all getting it? The magnetic devices are non-volatile, which means it don't want any continuous power supply because it is a magnetic device. Are you all getting it? Yes. And that is the main reason why you perform saving process. Please understand, anything that you have, if you're performing saving process, that means whatever is present on the RAM, you are going to store it permanently in the hard disk. This is what is the process of saving. Save process means this only will happen, that's it. Are you all getting it? Everyone? Online students, I hope I'm clear till here to everyone. Online students, please confirm. Yes? Okay. Now, if at all it is present on the hard disk, again, let me tell you, it will not do any work. Only it will store, that's it. You remember this. Now, again, if you want to open that program, what you will do, you will double click on it. Correct? You'll double click. At that time, you will see one icon like this, it will be rounding. It will take some time. What you will tell at that time? No, see, let's say you want to open WhatsApp, okay? WhatsApp is there, right? You will click on WhatsApp. It will take some time and then it will open. What you will tell that time? It is loading, you will tell. Don't you think you will use this word, right? Everyone, you will use this word, right? I have some document. If I want to open that, I'll go and double click on it. When I double click on it, it will just take some few seconds and it will open. At that time, what you will tell? It is getting loaded. It is loading, you will tell. Yes. So what do you think that loading process is? We are using the saving, loading, all these terms we are using. But what exactly is happening? What exactly is happening is loading is nothing but anything that you have will be stored where? It will be stored on the hard disk. Now, when you want it to become active, you want to process it, it cannot do any process on the hard disk. That time, what will happen is, it will get loaded onto the RAM. That is what is loading process. Saving means saving the file from RAM to hard disk. What is loading? Hard disk to RAM. Loading is nothing but the process of taking the document and loading it onto the RAM is what is loading process. That's it. Nothing else. Is this clear to everyone? This is what will be happening internally. And dear students, anything that is present on the hard disk, we call it as file. We call them as what? File. Are you all getting it? But anything, if the same file, when we load it on the RAM, we should not tell it as file. Are you understanding? These are the technical terms because you all are technical engineers now. Are you all getting it? When it is saved on the RAM, when it is saved on the hard disk, you call them as files. But when it is loaded on the RAM, you have to call it as byte. We call each of that as bytes. Is this clear to everyone? Yes. So now what will happen? Any document that I have, any file that I have, I will load it on the RAM. Now this byte will be given as input to this microprocessor. Microprocessor will easily perform the execution and it will give me the required output. Is this clear to everyone? Understood everyone? This simple it is. Are you all getting it? This is very, very important. Now, you might tell, ma'am, this is very fast, ma'am. Why should we need a hard disk then? Only these two are enough, right? Are you all getting this doubt? Everyone, online students, I hope all of you are getting this question. However, I told this is also semiconductor device. This is also semiconductor device. We have connected it. So good balance is there. Good compatibility is there. Why do we need this third device, ma'am? Instead of having hard disk, can't we have a bigger RAM? Definitely we can have, but there is one problem. What is this problem? There is no problem with RAM. There is no problem with microprocessor. What is the problem is semiconductor devices are very costly. Are you all getting it? Semiconductor devices are costly, but magnetic devices are what? They are cheap. They are affordable. Are you understanding? So the question which I asked you, if at all you want to buy a phone which is of 128 GB storage, 8 GB RAM, 128 GB storage, 12 GB RAM. If you have observed, you could have also seen the difference in the price also. Storage will be same, 128 GB, okay, but RAM is here 8 GB, here 12 GB. There will be price difference also. And for 8 GB, 12 GB RAM only, you're paying that much. Think 128 GB RAM, if you want, how much you have to pay? Paying not extra, how much? It will end up some 10 lakhs, 20 lakhs. Are you understanding? Okay. So whatever you tell that 128 GB storage, that storage is this. That 8 GB RAM, 12 GB RAM phone, what you will tell in that will be this RAM. Are you all understanding? Now we are getting to know why that price difference will be there. Same phone, same storage, but RAM size will be different. When RAM size different, price also will be different. Are you all getting it? Just for 8 GB RAM, 12 GB RAM, you are seeing the difference in some thousands. 2,000-3,000 difference will happen. Think about if you want to buy with 128 GB RAM size. Are you all getting it? That is why the systems will be designed in this. And dear students, out of these two, because both are memory devices, please understand, RAM is also memory device, hard disk is also a memory device. But do you know which is the primary memory device out of these two? Guess. Online students, guess. Both of them are memory devices. I have explained what really it is. Everything I have explained. Now, what do you think? Which one is the primary memory device? Is it RAM or hard disk? Online students, I want your responses here in the offline. Hard disk. Okay. All of you will tell hard disk. RAM. Okay. RAM. Suleiman says RAM. Varshini also is telling RAM. Okay. Good. Others, to which you vote? Is it for RAM you vote or for the hard disk you tell? Which is the primary? I hope you know what is primary, secondary. Primary means which stands as the first one. Secondary means as the second one. So what do you think? Out of these two, which one they tell us primary device, which one they tell us secondary device? Quickly, I want your answers fast. We have to go. We have to proceed for the next concepts. Others in the meeting. Yes, Bindu, Nikita, then Meghna, Mubina. Are you all there in the class? I want your answers. Nazir, RAM, okay, good. Okay, let me tell you. Which is the primary device is? Which one? RAM. And hard disk is the secondary device. Is this clear to everyone? Yes. So this is about the memory management in any of the computers. Again, in your phones also, because I told computers, your phones are also computers. Are you all getting it? It is just modified. Is this clear to everyone? Yes. Now, understanding this is very, very important. Why? Because in the next thing, there is something that is linked. The next concept which we are going to discuss is also linked for this. Is this clear? Okay. So everyone quickly take down the heading as memory management. Take down the heading as memory management and copy this. Quickly copy this. I will proceed for the next topic. Is this clear? Everyone? Okay. Tell it as memory device, memory management, and quickly copy this. By the time you copy, I will be repeating again. Those who have really some confusion, please listen to this. You already know there is one memory device which is called semiconductor device, which is a microprocessor. And I have also told this microprocessor is the one which is very, very mainly responsible for the execution, any process to happen inside a computer. According to that, we should also understand few of the other devices, that is the memory devices. And when we talk about it, there are two memory devices always that will be present when we take up a computer. One is RAM, other one is hard disk. This hard disk is a device which is made up of magnetic technology. RAM is a device which is made up of semiconductor device technology. But which is the one that will be directly connected to the processor? It is RAM, not the hard disk. Why, ma'am? I will tell you the reason. Why? Because if in case you connect hard disk to the microprocessor directly, what is going to happen? The compatibility issue will come. That is very fast. This is very slow. So that is why RAM is present in between. RAM will be directly connected to processor, and on the other side, RAM will be connected to the hard disk also. Now you might also get this question. You might get this doubt. Ma'am, then this is fast, this is slow. Here also compatibility issue will come. Yes, this thing might come. But why that problem will not come is, what did I tell? Before execution, anything that is present on the hard disk will be loaded here. So when it is loaded, directly it will do the work. That is why it will load from there to here. Are you understanding? So any execution should happen, will not happen on the hard disk, will happen on the RAM. So if you look at the RAM, there's one more thing. RAM is such a device which needs continuous power supply for the processing. Anything that you have it on the RAM is not permanently saved because it's a memory. I told you might think that it will be permanent. No, it is not permanent. It is something that it is volatile. Okay, volatile means it needs continuous power supply. But on the other side, this hard disk, which is a magnetic device, is non-volatile. Means it does not need any continuous power supply. That is why, if at all we want to store anything permanently, we save it on the hard disk. So what is saving? Saving is a process in which we are going to have the files saved or have the files permanently present. That is what a saving process. Now, if at all any work is there, if at all that is present on the hard disk, if we want to use that, if we want to execute that, we have to load it onto the RAM, which means we have to bring it from hard disk to the RAM. That process is only called loading process. Is this clear? And anything that is present on the hard disk, we call them as files. Any of the same thing when we shift it, when we load it on the RAM, it becomes bytes. We should call them as bytes. Is this clear? And also, the semiconductor devices are costly and the magnetic devices are cheap compared to these semiconductor devices. That is why always we will have two memories. One is primary memory, other one is secondary memory. And in this way, they will balance the memory units. Is this clear to everyone? Yes. So please make a note of this and then I'll proceed ahead for the next concept. Online students, please make a note of it. You can tell it as memory management and write down that. Online students, is it completed? Online students, is it completed? Please respond. If yes, I will proceed ahead for the next concept. Yes, okay. I assume most of you have completed it. Very good. Okay. What is the next thing? Dear students, very important thing we'll have to discuss now. What is that is? I hope at least once, let you be from any branch, okay, you would have definitely written at least one program, one C program, at least. You come from any branch, at least one program you would have written. Yes or no? Yes, right? I will not ask you to write any program. I'm asking at least once you have written, right? Online students, what about you all? At least once you would have written some program. Ma'am, why are you asking this? I'm telling, right? I will not ask you to write any program now. Why this question? I will tell you, okay? MUP. Usually we tell microprocessor as MUP. Okay, that is what I've written. Okay. Ma'am, why? Hello World program, Ravi Kiran. Nice. So, okay. Now, a simple program I will write. Okay. A simple program. Maybe a C program. Ma'am, we are for Java, ma'am. Why are you writing C program? I know we will be learning Java because since many of us have not known how to write a Java program, that is why I will write one simple C program. Very, very simple program. Observe. Tell me, if you want to write a C program, first thing you have to do something. What is that? Very good. Very nice. I'm very happy to listen to this. I think I'll write it here. You write like this. Ash include stdio.h. After that, very good. Ash include on your dot h. Do you know why we write that? Header files. Yeah, they're called header files. But what is the purpose of writing that? No, you can tell. What? Yeah, no, I'm asking. We call them as header files. Like, any idea why we have to write that? Any idea? Okay, okay, okay. I'll give you enough time. Maybe after this, you will tell void main, correct? Like this, you will tell. After that, you will have one flower bracket. Yes. Maybe I will tell one int a, maybe I'll tell is equal to 10. Maybe I'll tell int b is equal to 20. And maybe I will tell int c is equal to a plus b. I will tell. Now, if I want to also print that value, I'm going to tell printf. Yes? Printf only, no? Then inside double quotes, Ampersand. A or D or C? C. We have to tell ampersand D. Correct? Yes. Yes or no? So I'll just keep it this much. I don't tell I have written the exact correct program. Okay. But something like this you write. Now, you want to save this program. Please tell me how you save it. Ma'am, Control S. That is not what I'm asking. Maybe I want to give a name to this. Yes or no? If I want to save this program, I have to give a name to this. Maybe I'll tell the program as addition or add. After add, you will tell dot C. Everyone agree? Online students, do you all agree with me? You will tell like this. Dot C, you will tell add dot C. Everyone, please respond. Yes, right? Very good. Now, my question to all of you is, what is that dot C? Can anybody tell me what is this dot C? Yes, very good. To indicate that it is a C language program. Nothing but this file contains a data which is belonging to C type or C language type. But exactly if I have to tell what is this dot C is, we tell them as extensions. We tell them as extension. I will give you one more clarity. Let's say you will take photos, right? Have you seen the photo, how it will be stored? When you click one image, you know what extension will be there for that? No. Maybe you have heard .img, .jpg format. Yes, this is what the image will have. This extension are for images. Say suppose you have a video. If you are saving a video, it will have the dot extension as MP4. If in case you are storing some song, means audio, it will be MP3. Now we are able to relate. Everyone, online students, you are all able to relate this. Have you all observed? The videos, if you have observed, will have the extension as .mp4. Audios will have the extension as MP3. And the images will have sometimes IMG, JPG format. Everyone, please respond. Online students, please respond. Yes. Similarly, now this program, whatever is there, is a C program. That is why we will have the dot extension as .c. If in case it is a C++ program, you will have the dot extension as .cpp. Are you all getting it? If you're writing a C++ program, you will tell add .cpp because C++. Similarly, now when we will start writing the Java program for our files, we will be giving the extension as .java. Are you all getting it? It will indicate what type of file it is. Because later it has to execute, right? It has to identify, the system has to identify, the processor needs to identify what type of file I'm trying to execute. With the extension, it will make out what type of file it is. Is this clear to everyone? Understood? Great. Now, when you have written that program and you have saved, where it will be present? Here or there? This program when you have written and you have saved, where it will be saved? Hard disk. Very good. Now that add.c file is there, right? That add.c file is present on this hard disk. Now, this is present in which level language, dear students? Program is present in which language? C language, whether it's a high level language, machine level language, or assembly level language. It is a high level language code. Are you all getting it? This is a high level language code. Now, if I directly give it for the execution, will the processor understand? No, it will not understand. Before that, what I have to do? I have to compile it. Are you all getting it? That simple it is. Now, I am going to give it to the compiler. Now, compiler is one software. So, I am going to give it to the compiler. Are you all understanding? Because directly if I give it to the processor to process and give me the output, I will not get the output because it is present in the high level language. So I have to give it to the compiler. Now what compiler will do? It will compile this program and it will give me the file. It is going to give me one more file. Yes? What file it is going to give me? Do you know? Do you know which file it is going to give? After compiling, what compiler will do? What it will do? It will take the high level language code, compile it and convert it into machine level language code. Compiler means that only, right? In the very first day I told, what is the work of the compiler? To convert the high level code to machine level code. Now this compiler, what it has done? It has taken the high level code, whatever we have given, and converted it into machine level code. So that code, when it is converted, will not be .c. It will have the extension as obj. We call it as object file. Are you all getting it? After compilation, whatever the file we have got, we call it as object file. Here it was a C file. Now after compilation, it is an object file. Dear students, all of you concentrate now. Why? Because now there is one more important thing you have to understand. What is that is, hash include stdio.h, hash include conio.h, and you have written a program. If in case I ask you, whatever the program you have written, is it a complete program? Is it a complete file? If I ask you, I will tell you this is not a complete file. Ma'am, we have written complete code. Why are you telling it is not complete file? Why I am telling you is, hash include stdio.h you told. This is something called some library files. Have you written what this stdio.h should do? Have you told that? You have just told include. Include means include those files you have told. Where have you told what should be there inside this? You have told include conio.h. stdio.h is nothing but standard input outputs, connection input output. That is what it stands for. You're telling these two things to include, but who have written the code for it? There should be some body for this code, right? For this code, there is a body. Similarly, for this and this also, there should be some body. But are we writing it? No. Who have written it? The inventors of C program already have written it. That is why we are telling it is already there. Please include it here. Are you all getting it? So you are not including it. Whatever the C file you have written, the same add.c file, when I've saved it here, please understand this is a incomplete file. This is an incomplete file. Similarly, after compilation, whatever I have got, the object file, this is also incomplete file. If I give the incomplete file for the execution, will I get the output? No. How I have to make it complete, ma'am? How we have to make it complete is, that is when it will be given to one more software. What is that software? We call that software as linker. There will be one software. Who is that? Linker. What this linker is going to do is, this linker work is only this. That hash include stdio.h is there, right? That file has some body I told, right? Then hash include conio.h is there, right? That stdio.h, conio.h, all these files are there. Are you all getting it? Now, these files, when we tell hash include, they should be linked to this. That is what we have told in our program, right? So this linker is the one. What this linker will do is, it will take the object file and also it will take this library files. We call them as library files. And it will link both of that. Are you understanding? This, whatever this is there, the stdio.h, conhio.h, we have told to include those files. Those files, as soon as when you download and install C, you will install C programmer, right? So when you install, they will get installed and it will be already present in your hard disk. When you are trying to execute it, before the execution, this linker software is there, right? It will take your object file, which is compiled, and it will take these library files. It will link. After linking, it will generate one more file. And that file is what we tell it as add.exe. Nothing but this is the executable file. Are you understanding? And this is the complete file. Is this clear to everyone? Till now, it was incomplete file. Now, after including the necessary library files for it, one file is generated. And if you observe, look at the extension of it. What is the extension? It is .exe, which means it is the executable file. Now, what is going to happen? There is one software. Who is that? Loader. What loader will do? Loader will take this executable file and load it on the RAM. Now that executable code is present on the RAM. But here we call it as executable byte. We have to call it as executable byte. Executable byte. Now that add.exe is loaded here. And when we give this through the bus to the microprocessor will execute and give us the required output. Is this clear to everyone? Understood? Maybe till now in your graduation, you would have written simply -- include. I don't know how many of you were really knowing. We call them as library files. Ma'am, why are you telling this now? Why I'm telling this now is because similarly in Java, we are going to make use of so many classes. Ma'am, what is classes? You will understand. Don't worry. So many methods we are going to use. For all of that, we are not going to give the body for those files. Who is there? Already James Gosling and his team, they have written and they have kept. When we download JDK, that is the Java things, when we are going to install the Java things, along with that, even these will come and sit in the hard disk. Are you all getting it? During that time, what will happen? Those library files will be linked and we will get the executable code for us. That will get executed. Is this clear to everyone? Understood clearly? Yes? How the processing of the things happen when you write a program? All these things are involved behind. We will just tell, write a program that F9, F2 you will press. F2 for compilation, then F5 for execution, F9 for execution. Those things, ma'am, we got the output, we will go. Yes, or sir, we got the output, you will go. This is what you would have done in your labs. But internally, all these things will be happening. Is this clear to everyone? So very quickly, I will just give a brief of whatever I have explained till now so that you can make a note of it. So please understand, dear students, any program you write will always be, when you write and save it, it will be saved on the hard disk, and every programs will have the extensions. Like if at all it's a C program, we will have the extension as .c. If at all you are going to store the images, I want all of you to do this. This is a homework to everyone. Once you go home, if at all you have not seen, go to your photos, click on that and tell details. In the details, you can see that it will be stored as .img or .jpg. Similarly, videos, you won't see the details. It will be present as MP4. Audios, some downloads will be there, no? Audios like music, something and all. Those things you see, it will be MP3. Like this, every file will have different extension based on which type of file it is. So for C file, we will have the extension as .c. When we store it here, this file is an incomplete file. We write it in, and definitely it will be in a high level language. Why it is incomplete? Because there are few library files which we will include in it, but we are not going to tell any of the body. We are not giving any body for those files. It is already priorly present. So that is why it is incomplete file. When we give it to the compiler, the work of compiler is to take the high level code and convert it into machine level code. That will be generated. But when it is generated, this is also incomplete file. Now we cannot give the incomplete file to the RAM for the execution because it is incomplete. That is the reason. Then what will happen? There was another software called linker software. What linker is going to do? Linker is going to take the object file. Now after compiling, the file which is generated is going to be object file. Is this clear? So object file, it will take all the necessary files, it will take, it will link, and it will generate the exe file. What is exe file? With, if you have the extension as .exe, that is the executable file, means which is executable, as the word itself says, you can execute it. Now this is a complete file. This complete file will be taken by the loader software. Loader software, what it will do? It will take the executable code from the hard disk and load it on the RAM. Now on the RAM, this is present and it is processed for, and it is given to the processor. Processor will process it and give the required output. Is this clear? Everyone? Everyone? Online students, did you all understand this? Everyone, please respond. Okay, now you all can start writing. Online students, did you all understand this? Only one, Varshini understood. Okay, Madhu also understood. What about others? Okay, Nazir understood. Great. See, if you don't tell yes, I'll assume you have not understood. Okay, now I can see Ravi Kiran, Meghna, okay. Then Nikita, okay. Mubina, okay, slowly. Yes, I'm getting. Lenadish, nice. You understood? Yes, great. Any confusion, online students? Anybody have any confusion in any point? Whatever we discussed now? I hope no confusion. And also, yeah, one more important thing. This executable file will be present in which language? In machine level language. Are you getting it? This also. This executable byte is present in machine level language. That is the one which it will understand. Okay, please make a note of it. Then we will proceed for the next important topic. Online students, is it completed? Here, you're writing still? Completed? Right, okay, take time, right? Anybody is still writing? Online students, is it completed? Can I erase it? Online students, shall I erase this? Have you all completed? Okay, Hemant. Hemant, is today your first day? Because I think I'm seeing your name for the first time. Madhu, is it your first day, Madhu, today? Yes. Okay. So, Madhu, I hope you know that today is the third day of class. We have already finished with 2 days of class. You can please reach out to our team. You can get the record. You will get the recordings of last 2 classes. Okay, you can go through those recordings. You can watch it, and if you have any doubts, you can reach me. Okay. The same thing. If at all there is any new students in today's class, please make sure that you can get the recording. You can take the recordings access and you can watch it. Whatever the discussion has happened in the last 2 classes. Okay. Okay, I assume all of you have completed this. I will go for the next important topic. I told Java became so popular, and today also it is that popular. It is in the top 3 because Java happens to be a portable programming language. It is something called platform independent, I told, right? That discussion is what we will start now. The very, very important discussion is what we are going to start with from now. That is completely about Java. Is this clear? Everyone? So what really is that? I will tell you. So what is that is, even before we talk this portable platform independent, I will tell you, or maybe I want to ask you, what do you mean by this platform? Platform independent, we will see next. First, we will understand what is this platform. Anybody can tell me, according to you, what can be platform? I'm telling platform with respect to softwares, because when you tell platform, suddenly what comes in mind? Railway station, railway platform, correct? Yes, yes, but that is not what we are thinking about. The software, from software perspective, what is a platform? Online students, any answers from your side for what really is a platform? Anybody is going to tell me what really is the platform? Google, huh? I know you all are very intelligent, huh? Okay, let me only tell you. Platform is combination of two things. Are you all getting it? Platform is a combination of two things. What are these two things is? One is the hardware, other one is the software. Combination of hardware and software together is what we tell as a platform. Hardware means what? Hardware means the processor. Nothing but the microprocessor. Software means what? Software means operating systems. Are you getting it? So combination of the microprocessor and the OS, the operating system, together will tell us one platform. Can you just name some of the microprocessors which you know? If I tell, I know you will tell. Can anybody tell me before I tell? Intel i3 processor. You would have seen on your laptops, right? One chip design will be present on that i3 processor, i5 processor, Intel, like that it will be present. Now, more of AMD processors you are seeing. Yes. i5 processor, i7 processor. Now i7 is what Windows is having more of the time. i5, i7, all these things. Okay. If at all I have to show for the offline students, I can just show here. Can you see? Here. Online students, in the laptops, you can see there. In the corner, you would have had where your keyboard is present. They would have written there. I mean, you would have had a chip. On that, it would have written one sticker like. This is what a processor is. OS, which is the OS? Something called Linux. Windows. You've seen, right? Windows. Windows. Mac, Macintosh. Which one is Mac? iPhone, iPad. There is like iPads, right? iPads. I mean, the MacBook, AirBook, they tell no. All of that is having Mac OS. So, combination of both of these, i3 processor with Linux, i3 processor with Windows, i3 with Mac, or AMD with Linux, AMD with Windows. It can be any combination. Both the processor and the operating system together, we call them as platform. Is this clear to everyone? See, in the screen also, when you minimize the screen, what is visible? It is going to show, right? Some icon like this. See, I'll just display here. Everyone just see here. If in case, I just have to tell it. Okay, I don't have it here in the background. Wait. I'll just show it here. It's not working here. Not a problem. Got stuck. Okay. So you would have seen, right? You whenever you're purchasing a laptop, that Windows will be present. If at all you're purchasing Mac product, it will be Apple product, it will be always Mac. Similarly, sometimes you can also have the desktop and laptops with Linux. These are the operating systems. I'll show it in the next class. If it's not opening there, I will show it. Is this clear? So these combination, both the processor and the OS together, you call it as platform. Okay. Now on this, how really the C language failed because it was not a platform independent. How Java became platform independent is what we will understand now. Is this clear? Quickly make a note of this. Tell it as platform and write. Platform is combination of hardware and software. Examples, you can tell this. Processor and OS. These are the processors and these are the OS. Quickly make a note of this. I'm going to erase it even before I start with the next discussion. Online students, simultaneously, please mark your attendance as well. The QR code is, the link is posted in the chat. Kindly mark your attendance. It's completed, right? Yes. Now, very important, I want everyone to observe. Let me tell, I have one computer with me. Okay. Ma'am, this big computer. Yes, this big computer. Why? Because I have to tell what and all is happening inside this computer. So there's one computer. Now, let me tell the platform for this. Okay. Let me tell, maybe this is a computer which is having some, which is a Windows. I'll tell this is the Windows, which is having Windows as the OS, operating system. And maybe the processor is i5 processor. Are you all getting it? It is an i5 processor. Now, dear students, what is going to happen is we are going to write one program. Okay, we are going to write one program here. That program, whatever we have written here, is a high level program. Maybe I'll take this add.c only. Now, what will happen next? I am going to give it to the, yes, very good. I'm going to give it to whom? I am going to give it to compiler. What compiler will do? Very good. It is going to generate the machine level code, but here it is the object file. Yes, I agree. Next, what will happen next? The linking. Dear students, I told previously, linker is one software, loader is one software, right? But later what has happened is there is a software which is combination of both. We call them as linking loader. What it will do is it will link the library files and it will load it to the RAM. That is what it will do. Okay. Now this file is given to whom? This file is given to linking loader. Both the work this one software only will do. It will link the files and it will give the, it will load it on the RAM. Now here I have the RAM. Oh, sorry. Let me tell, this is the RAM of the computer. Okay. Now, this linking loader, what it will do? It will link and load that add.exe file. Agree? Everyone? And definitely this is present in machine level language and this is a complete file. Everyone? Now, this is given to whom? This is given to processor. As I told, which processor we are having here? Windows operating system, and we have i5 processor. Is this clear to everyone? Now, there is no problem. There is no problem. When I give this it will give the required output. Is this clear to everyone? This is one case. Maybe I tell case 1. Is this clear? No problem. Every process happened on this computer properly. And what is the platform of this? Windows with i5. Okay. Now, what I will do is, I have one more computer now. Is this clear to everyone? What I will do in the second case, please observe carefully. It is very, very important. In the second case, what is happening, I'm going to tell you. Now, this is a particular machine. This is one computer, which is having, probably I will tell, this is also Windows. This is Windows with i3 processor. With i3 processor. Okay. Now, whatever the add.c file is there, I write it and save it on this, which is a high level language code. Are you all getting it? Now, I give it to the, I have to be more specific, it is a C compiler. Because for Java, Java compiler is there. For C++, C++ compiler is there. So which compiler is this? This is a C compiler. I'm going to give it a C compiler. No problem at all. Now what C compiler will do? It is going to generate the object file. It will generate the object file which is present in machine level language. Now what I will do, I will not execute it here only. I am going to take this object file on another computer. I'm going to take this file on another computer. Are you all getting it? Ma'am, why this? I will tell you a scenario. Why I'm going for the another computer. Now, you are working in one company. When you're working in one company, in your company, everyone are using Windows. Now you have got one project. For some client, you are developing something and you're giving. One software you're developing and you're giving. That client is present somewhere in some other country. Let's say in America, they are present. Now you want to send your file. But which computer they are using? They are using Apple computers. Yours is Windows. They are using Apple, Mac computers. Platform is different, right? So file, whatever you have written and compiled, you will send it to them. Now let us assume to your client whom you have sent, which operating system they are having? They are having Mac operating system. Are you all getting it? And maybe the processor is i7 processor. Are you understanding? Now, what you will do, you will take this object file and you are going to send it to them. You have sent to them. Now, what these people will do when you have sent you, they will download that. Are you understanding? They are going to download it. When they are going to download this add.obj file, which is in machine level language, they will give it to the, first thing is, it will be given to whom? It will be given to the linking loader, because all the necessary files it has to load. Are you all getting it? Later, this will be generating the what? The executable code. EXE is nothing but executable code. Now, dear students, if you try to give it to the processor, what is really happening is processor is not giving any output. What is happening? Processor is not giving any output. Why? That you have to understand now. Very, very important. Why? I am going to tell you that now. Please listen, everyone. When you have compiled it, where you have compiled it? You have compiled it in one computer, which is having the platform as Windows operating system with i3 processor. But when you are trying to execute it, if you have executed here only, there wouldn't have any problem. That is what happened in the first case. You compiled in one system, you executed it in the same system, so no error was coming. But now you compiled it on one system and you send that object file to another system which is having a different platform. This is Windows with i3. This is Mac operating system with i7 processor. The platform is different. When you're trying to give, what has happened is this object file which is generated, it is compatible for this platform, for Windows i3. It is not compatible for Mac i7. That is why when you try to execute it, you are not getting the output. So here there is no output. Are you understanding? Are you understanding? Which means if you are observing what really the C language, the C program, what really it was happening is it was able to execute, compile and execute on the same operating system. If you try to compile it in one system and execute it on another system, it was not happening. Are you all getting it? The same thing here, when you have made it, you have generated the object file, when you have compiled it, here with respect to this platform, it was compatible. When you're trying to give it to that, it is not compatible. Compatible means it is not supporting. Are you understanding? It is not supporting because this is a different platform. This is what you called platform dependency. It is depending on the platform. Understood? Everyone? Understood what is platform dependency? If you have understood this clearly, next I will explain the platform independent. How Java became platform independent. That reason I will tell. I mean, that explanation I will give. Is this clear to everyone? Offline, all of you, it is clear? Online, everybody, it is clear? Please respond. Online. Online students, is it clear? Where we execute the code. Madhu, yes, we are going to execute the code. Maybe with respect to this you are asking, or where, Madhu, you are asking about this? So is this clear to everyone here? Yes? Okay, please take down the heading as platform dependency. Heading as platform dependency, and copy both the cases. Tell case 1 and case 2, copy both of this. Everyone, please write this. Online students, everybody please write this. Tell it as platform dependency and copy this. I hope all of you understood why C language was not a platform independent. This is the reason. How Java became platform independent, I will explain next. Online students, is it completed? Please confirm. Have you all completed it? Okay. So this is about how C is really failed becoming platform independent. Okay. How Java became platform independent is what we have to discuss next. It takes time, so I'll keep the class till here for today. What is this platform independent? What really is happening with Java program? Internally, there are many things that you have to understand. That is what would be our next discussion in tomorrow's class. Is this clear? So we'll keep the class till here for today. Any doubts, you can reach out to me, and let's all meet in the next class. Please do attend next class so you will understand what really Java is all about. Is this clear? So thank you, and let's all meet in the next class. Online students, if you have any doubts, you can just put in your chat in the chat box. If not, you can just leave the meeting for today, and let's meet in the tomorrow's class.